Every new generation of wireless technology arrives with the same question, and it is worth asking properly. Sixth-generation networks may use some of the highest radio frequencies ever placed close to a human body. If you have wondered whether that is something to worry about, the concern is reasonable. But 6G is not a single frequency, and it is not a single signal either. It is a standard, a set of agreed rules that lets equipment combine many different bands. Some of them sit below 1 GHz and reach a long way. Others sit far higher and carry much more data over shorter distances. The word radiation does the rest of the damage. It covers radio waves, microwaves, visible light, ultraviolet, and X-rays, and those things do not behave the same way when they meet matter. Only the high end carries enough energy per photon to break chemical bonds. A photon at 300 GHz is thousands of times too weak for that. Everything 6G uses sits below the line. Non-ionizing does not mean harmless at any level, though. Strong radio energy heats tissue, and enough heating causes damage. That is why the same kind of wave can be completely uneventful at low power and genuinely hazardous at high power. What changes is not the nature of the wave. What changes is the dose, which is why safety limits are written in watts per kilogram. So what actually determines the dose? 5 things, and they only mean something together. The frequency, because it decides how the energy behaves in tissue. The power, because it sets how much energy there is. The distance, because intensity falls away quickly. How much of that energy the body absorbs and how long the exposure lasts. Change any one of them and the answer changes. That combination is what gets measured. Here, intuition usually points the wrong way. Higher frequency sounds like it should push deeper into the body, but the opposite happens. At millimeter wave frequencies, the energy is absorbed within the first millimeter or so of tissue, mostly skin, at the surface of the eye. Lower frequencies, a few gigahertz, reach considerably deeper, so the highest bands are the ones that penetrate least. There is one thing here that genuinely is new. High-frequency systems steer their energy into a narrow beam rather than spraying it in every direction. No extra energy is created. The same energy is simply concentrated where it is needed. When the beam points at your phone, exposure is higher than an old broadcast antenna would give you. A moment later, it points elsewhere, and exposure falls to almost nothing. Direction and duration matter as much as power, so real systems have to be measured, not assumed. And here is the encouraging part. Every change 6G brings pushes absorption downwards. Denser grids mean shorter links, so each site transmits with less power. Better links mean your own device turns its output down, and your device is the transmitter closest to you. Higher frequencies keep their energy at the surface instead of reaching deeper tissue. Measured on real networks, the energy a body absorbs sits far below the safety limit. So 6G adds no absorption to the levels and bands we already live with. Its distributed design gives us less.